The TILTA Nucleus Nano, a great device that adds power, zoom, or focus control to almost any lens, a DSLR mirrorless cine-style lenses, a solution that adds flexible linear zoom or focus control from the comforts of a wireless handheld controller. First, we'll start off with the unboxing of the Nucleus Nano, followed by the installation of a rubber gear ring, and then the install and setup of the Nucleus servo and controller. I'll show you how to calibrate the servo with the wireless controller and show you a few shots zooming in and zooming out. I'll put timestamps in the description below, so feel free to either watch the whole video or skip to whatever part you need. Either way, if you do like this content, it would help me out a lot if you could like this video and also consider subscribing. Forever shall I be grateful. And so without further ado, let's get to it. Within that box, TILTA provides a great soft storage case for the whole controller system. Alright, let's start underneath the lid. So first off, you get TILTA's literature, which includes their user guide and what looks like a warranty card. They do provide a pair of universal gear rings that you can snap to the right size, but I'll show you a better looking alternative. Like this one here that we're going to install a little later on. So you get a 15 by 100 mm black aluminum rod to attach to the servo. A battery charger for the two proprietary batteries that are provided, a huge improvement from the first iteration charger, which was that. There's a micro USB power cable for the servo if you are using the Ronin S gimbal, like you see right there. You get a regular micro USB cable, and a micro USB to micro USB cable, probably to provide power to the servo from the micro USB on certain cameras. You get a hand wheel attachment plate for the Ronin S G2X, although you could use the provided quarter 20 hex screw to mount the plate to a female quarter handle like this. You got these ominous AA looking batteries that can only be used with this TILTA's hand wheel controller. Don't try to use regular AA batteries because the voltage is way lower than the 4.7 volts provided by those red batteries. Here's the hand wheel controller with a small OLED screen record button that also functions as the power button, more buttons, and a micro USB port which you can use to power it up, as I'll show you later. That's where you attach the mounting plate from earlier. And there's the battery compartment right there. Snaps just like that. And the muscles of the system, the servo. It feels very solid, built very well. There's the micro USB port. Another OLED screen with two buttons next to it. That there is the 15mm single rod mounting base plate where you would slide the provided 10cm aluminum rod. You get a bag with M6 and M4 Allen keys, also with 1/4 inch 20 hex screws. You might not need this, but it's a hand wheel attachment adapter for the Zhiyun Crane 1. And that's all in the box. Like I mentioned earlier, I'm just going to show you that the wheel can also be powered up with a power bank using just the provided USB to micro USB cable. So let me take the battery out. I'm going to close the compartment. One thing to note is that once the cable is plugged in, the wheel turns on immediately, which, unlike using a battery, has to be powered on manually. Turn the controller off, hold down on the red record button, and the display will start counting down 5 seconds, and it powers down. Another thing to keep in mind is that once the controller is turned off with the micro USB plugged in, you won't be able to turn on the device with the power button, which I'm trying to do right now. It's now starting up. So the only way to start it back up is to take out the micro USB cable and plug it right back in. However, this is not a problem when using the provided battery. It starts up right away. Okay, I'm going to place the battery back in. And it doesn't start automatically as expected. You got to press the power button. And then to shut down, you hold the power button. Next up is adding the rubber gear ring. You could use the provided universal gear ring. However, if you know the diameter of the lens you're working with, there is a more cleaner setup which avoids a piece of rubber sticking out from your lens like this. And also it provides a continuous ring of rubber teeth for the servo gear to attach on. TILTA has their own lineup of rubber gear rings based on common lens diameters. Before you buy one, you want to first confirm the diameter of the lens you are going to be using it with. In my case, I have the Sony a6000. So what I did, I went to the website that I bought my camera from and searched for the specifications of the telephoto lens that was included in the kit. So I have the 55 to 210 millimeter lens, and I need to find its dimensions in millimeters. That's also the lesser number, and in my case, it's 63.8 millimeters wide. You want to next go to Amazon and type in TILTA focus ring. I'll also have the link in the description below as well, and it should look something like that. Underneath the price, you'll find options for different sized lenses. However, you might not see your exact dimension, but as long as it fits within the range that they specify, it should be fine. In my case, it's 63.8 millimeters. So I chose the option that specified 62.5 to 64.5. Next up is the installation of the TILTA rubber ring. It might be a little bent up from packaging, and so you might just need to roll it out a bit to get it back into shape. As you may have noticed from the packaging, it did say focus ring, and sure, you can use it for your lens's focus, but in my case, I'm putting it on the zoom ring. Now with the lens fixed on your camera and with the camera on a soft surface, slowly finesse the gear ring down the lens's tube. Check alignment and you should be good to go. In the next clip, you'll see that I ended up moving the rubber ring closer to the camera body because of a slight problem that I'll demonstrate towards the end of the video. Basically, the problem stems from the zoom ring being harder to rotate than compared to the focus ring on my lens. This requires the servo to apply more torque to turn the zoom ring, and based on what direction the servo turns, that increased work causes a slight drift upwards or downwards on the lens and camera body in relation to the provided mounting plate. This can especially be noticed when you're zoomed in on an object. But on defense of TILTA, they did state that the provided mounting plate works for up to a 95mm lens. And I'm using a lens that's about 105 to 108mm long, and the lens can extend to 210mm. So I need me some other mounting plate. Let me know in the comments below. Next up is the installation of the mounting plate, the aluminum rod, the servo. So you want to turn the camera upside down and mount the provided plate on the 1/4-20 on your camera. And you use the provided Allen key. You could position the mounting plate further forward. However, in my case, to reduce lens drift, as I talked earlier, I wanted to have the servo as close as possible to the mounting plate. Next, you want to insert the aluminum rod to the base plate, and then tighten that with another Allen key that's also provided. After that, you go ahead and insert the servo motor to the rod. Just make sure the servo gears are facing forward and have adequate space to contact the rubber gear ring, as you see right here. Now, before you tighten the servo to the rod, we want to make sure the wheel controller can connect to the servo and actually spin its gears. Once you send power over to the micro USB, the servo should start up immediately. You want to next power on the wheel controller and sync them both to the same channel. You can keep pressing either the up or down arrow twice until you get to the right channel, and that's both on the servo and the controller. Just like that. And they're both on 8. Once the channel is set, there's no need to change it later unless you are getting interruptions in control or have other similar TILTA controller devices that you have. Just like that, the servo should move exactly to the movement of the wheel controller. Now you can place the servo on the rubber gear ring gently, just enough to contact the rubber teeth, and then once that's done, you can tighten the clamp below. Now, to calibrate the servo according to your zoom lens, hold the cal button on the controller for 3 seconds. The controller will vibrate at each second, followed by the servo spinning forward and backward. And what it's doing is determining the hard stops on this lens from no zoom to max zoom, and it programs it within the controller. And here's a few more shots of the TILTA Nucleus servo and controller in action. And as I mentioned earlier, you can see that whenever you change the direction on the zoom controller, the entire lens and camera body shifts up and down. I most likely need to get a larger mount, and probably specifically a telephoto lens mount that kinda has a clamp towards the front end of the telephoto lens where you can kinda strap the lens to the mount. I'm not sure if that would work, but it seems like it will. I'll show you a picture of it. That looks like it might work, but if you guys have any other ideas, any other solutions, please let me know in the comments below. The next and final clip will be an actual recording from my A6000, so you get to hear how loud the servo is in comparison to the background noise, which is a window AC fan. And it will show the capability and dexterity of the TILTA Nucleus controller as it actuates the zoom ring on my 55 to 210mm lens. After that, I'll finish out with some final thoughts. Hopefully a telephoto lens mounting plate and clamp fixes it. I will post a video on this once I do get it to work. My final thoughts. If there's anything to nitpick about it, it would be the lack of a battery status indicator on the wheel controller and some sleep mode the controller seldom enters when it's not used for a few minutes. But all in all, it's a great solution to motorize your zoom or focus rings. I hope this video has given you some greater insight on this controller system.